Assalamualaikum and a very good day. Okay, this video is for I want to respond from the question or the doubt that you have listed in the feedback that I asked you to fill in. So I think the first one is about the problem with the voice. Sometimes the voice is not clear, but I think if you refer to my first video, which is my greeting, and you can see that I'm using the earphones which is there's a mic that is close with my lips or my mouth, so that is the best that I can give, and hopefully that is the you can hear that voice clearly, because that is the best that I can give to you. And then regarding the second question, which is linear classification and logistic regression is different? Okay, this one I will before I try to answer this question, let me try to do some summarization from this whiteboard. Okay, so as you can see that again, let us try to review back what we have learned. Start from the first chapter. Okay, and then the first chapter. So artificial intelligence, you can see that there's a lot of method in artificial intelligence, and in your syllabus we focus more on machine learning. Okay, instead of machine learning, there's a lot of other technique which is not under the machine learning, but why we focus more on machine learning? Because that is the one that make the AI become popular today, is actually a machine learning. Okay, then you can see a lot of technology mention that they have a AI system inside their product. Actually, that is for marketing. You can see that they use the word artificial intelligence in their product, just to make sure that, I think that is because of the marketing, means that AI, maybe in marketing perspective, they see that using AI is better than machine learning to market their product. So that's why they are using AI. But actually, the one that make AI popular today is a machine learning, which is a part of AI. It's not the whole AI. And then even in machine learning, machine learning is divided into three. One is supervised learning, unsupervised learning, and reinforcement learning. And the one that make the AIs very popular today is supervised learning, as well as I think most of the technologies today that make the AI ahead is supervised learning as compared to unsupervised and reinforcement learning. And then again, in supervised, so what is the difference is that supervised learning, you need to give the data which consists of input and the actual output, means the X and the Y. So that's why they call it as supervised learning. It means that you are monitoring in the training process, in learning process. You give the question, you give as well the answer, so then the computer will try to see the pattern. What I meaning by question is actually the input. You give the input, you give the answer, which is the actual output. So now the computer try to learn according to what what are you provide to the computer. Means that you are supervise the computer. If you see this thing, then the output should be this one. If you see this thing, the output should be this one. So means that you give the question, you provide also the answer. So meaning that the computer will try to learn the pattern from the question, and then they try to relate with the answer, or try to relate with the input. You give the input and the output, then the computer to try to learn from the input and try to relate the input with the output. So that is why they call it as a supervised learning. You are supervise the computer. And then under supervised learning, it consists of two types, which is regression and classification. So, and again, the classification is the difference is that the regression, the output is continuous. Okay, the output is continuous, and then for the classification, the output is it can be either binomial or multinomial. So what is the meaning by binomial? Is this is what we call as, if the output is binomial, is a binary classifier. So what is the meaning by binary classifier? So binary classifier only give two output, means it can be 0 or 1, class A and class B, abnormal and normal. So meaning that the class is only 2. However, for multinomial, this is what we call a multi-class classifier. If the input is multinomial, then it is called as a multi-class classifier. Classifier. Okay, and then this one, the difference is that it can provide more than 2 classes. Means that if you want to have application that can categorize your input into more than 2 classes, then you can call that classifier as a multi-class classifier, or the output of that classifier is can provide a multinomial outputs. Okay, so so back to the previous lectures delivered by Dr. Ting. Okay, you have a linear method for regression. And another one is a linear method for classification. Okay, so you can see that I think some of you are a little bit confused when I talk about linear regression, and then I mentioned about logistic regression. So because actually what that have been delivered by Dr. Ting is related to linear regression and logistic regression, but because might be Dr. Ting use another reference from another textbook which use another word, another term for that, another name for that thing is linear method for regression and classification. Because I think some of you might be confused about the term that used there, but let me try to relate, and later when I use the word logistic regression or linear regression, then you can relate with the previous lecture. Otherwise it might be a little bit confused. What is actually, how does that relate with the previous lecture? So this is the term that Dr. Ting used in his lecture note. So, and then in classification, Dr. Ting introduced to you with 2 things. One is classification using sigmoid. Okay, and then using sigmoid, and then another one is using softmax. And then if you refer to the notes there, this one is actually this one is also considered as a binary classifier. Okay, binary classifier. And then this one is a linear method for multi-class classifier. So you can see that both both of this is actually is under, if you talk about this flow over here, it is actually is under classification. So just the difference is that this one is for multi-class, this one is for binary, or in other word, the output for this one is binomial, the output for this one is multinomial. So you can have class A, class B, class C, means that more than 2 classes. This one you can only have 2 classes. However, this one should, okay, of course, is about regression. Then this one is under regression, where the output is continuous number. So when I use the word linear regression, okay, when I use the word linear regression, is actually refer to this one. Okay, this one. This one is actually another name for linear method for regression, is actually linear regression. And then I always talk about logistic regression. What is the meaning by logistic regression? Is actually this one. Is actually this one. Logistic regression is that the classifier, the linear regression, but you are using the logistic regression. So linear regression is if you want to do if you want to have a continuous output, means that if you put this method, if you want to know this method is under which group in this flow, it is under supervised learning, which is under the regression. But for logistic regression, even the name is logistic regression, this one is not under regression. Okay, it's not under regression, it's under classification, because for logistic regression, they are using they just extend the linear equation in the regression and cascade with sigmoid function. So when you apply a sigmoid function at the output, means the input is a linear equation from the regression, then that is also known as logistic regression. Even the name there have the word regression, but logistic regression is belong to the classification under binomial category. So that is the thing. So you then you can clear about it. However, if you talk about extending the linear equation in regression and you apply the softmax, that is not a logistic regression. For that one, I think there's no special term for that. But if you are applying logistic sigmoid function before by extending the linear equation, then you apply the sigmoid function in this way, then there's another name for that is called as a logistic regression. Okay, I hope you clear about that. And then the rest is I think everything is clear, that the things that I make it, that if you have a theta not there, it will become bias, and then theta 1 to theta d should convert into W1 to WD. So, and then what the other question? Okay, since the linear regression is used and cascade with the sigmoid unit step to become a classification, why during the A and N the MSE will perform better? Okay, let's hold this question first. I try to answer. Okay, for this question, I think later I will because someone asked me to give some example calculation for NN. Okay, this one later, when, because I don't provide all material in the first lecture. Actually, later I will put a slide that we will discuss about how we calculate or the mechanism of A and N. I try to give you some simple A and N network, and then we try to do some derivation, all the calculation, and you will see that the flow, what happened during the training process and so on. Okay, that is and then okay, someone asked about I am wondering how to apply this method in real life problem. I think this one should be, you must understand this one at the beginning, means that when I think during the first not the first lecture, the first chapter, when we talk about the machine learning and so on, you should relate that one with the real life problem. Okay, I think Dr. Ting give you a lot of example, like if you have image, then you want to recognize the image. Of course, in medical application, for example, you have, I think the most popular applications right now in research is that there's a X-ray chest image to predict the pneumonia. I think that is one of the my previous FYP student project. We want to recognize to classify between normal pneumonia that related to bacteria, and another one is pneumonia related to virus. Okay, we try to recognize these three classes of image. So of course we need to use that the classifier, which is a multi-class classifier to do that. Okay, and then actually that X-ray chest image currently or recently have been related to the COVID-19. They try to have to obtain the data from the chest X-ray image that of the COVID-19 patient. So that is the one that shared by Dr. Ting previously. Of course, if you can extend that project, it will beneficial. It will give a lot of benefit to the humanity. So there's a lot of many examples there, but of course, because we focus more on supervised learning, what I can relate is that one of it in biomedical, and of course in general there's a lot of things can be done there. Of course, when you talk about for example, it's not just image, it can be like speech. Okay, speech processing. That's why Dr. Ting share about the application in speech processing, given the voice, and then the machine learning can recognize every word that you voice out, and then try to type in Word document, for example. So that is also the example of using the machine supervised learning. And then the next question, does gradient descent still used on this day? Which application and how much likelihood and FC different? Okay, this one the practical, I think this one is also related to this question, so later I will try to answer this one. Okay, this one and this one is almost similar. You want to compare between the MSE and the entropy. Yeah, which one is the best? Which one is better? And then I find it hard to distinguish the Septron algorithm with a linear classification. The block diagram is same, and I can okay. This one. Okay. Again, I always draw this block. Okay, you have a X, which is the input. This one is bool. X means that it's a vector. Okay, it's a vector, and then this is the linear equation or the linear operation. Of course, you need to actually you have a bool X and bool W. of course bold W, and then you need to, at this process, you need to if this is matrix, this is this vector, then you are doing a dot product there, or this one is related to the summation of product. So that's why another I think in my slide now they call it a sum of wake to find the output here. Actually, let's say I use the word V there. V is equal to sum of wake input. So sum of, so that's why the words. Let's go to my slide there. Go back to yeah, this one. The output here is equal to wakes, sorry, this one is classification. Yeah, the regression. Y head is equal to wake sum of the attribute. Wake sum of the attribute means that this is the wake W, and then wake sum of attribute means that you are multiplying each element in X and W, and then you sum it together. Or you can also, I think in some books they call it also as well as sum of product. If you remember when you learned digital system, W1 X1 plus W2 X2 plus W3 X3. So this is in digital system or system digital, you call as SOP, sum of product. So you can also consider this one, this operation, as a sum of product. Means that you are obtaining the summation of every product element between X and W. Okay. So back to the question there. So you can see that this block here is represent the linear equation or linear function there. So, and then in general, V is the output of the linear equation or linear functions there. Then you are cascading with another function, non-linear function F, to obtain your Y head. Okay. So like I said previously, if you talk about linear regression, we don't have F, means that you only have a summation, and then directly the output is Y head. Okay, this is your X. Of course, this one is W. But you can generalize all equation in this way. Doesn't matter is it regression or classification as well. How to do that? Let's say how actually I want to make sure that my block here as a linear regression can represent in this form. How to do that? Of course, one way is that if I set my F here as an identity function. I think those who learned biomedical image processing must know about identity transformation function. Of course, that is similar to this one, identity function. What is identity function? Identity function, any V is equal to Y head. Okay, so remember, this is identity transformation function. Means that is this let's say this is your V, this is Y head. If the value F of V is equal to W equal to the value of Y head, doesn't matter any points there, because this is identity function. So if you put if you set your f as identity function, this equation will become a linear regression, or this block, because this one, if you set as an identity function, it seems to be this one is not functioning at all. Means any v should be passed through here as a y hit. Okay, that is so in other words, this block can also represent regression, because if you want to do regression, linear regression in this block, you just replace you just set your f as identity function, because if this is identity function, any v there is equal to y hit. And then what is the difference between linear regression and perceptron algorithm? The perceptron algorithm, the f is not identity function. The f is the unit step function, which is this one, unit step function. If you find your v is negative number, then your y hit is equal to 0. If your v is more than 0, it will become 1. So that is linear perceptron. And then the disadvantage of linear perceptron, again, you can refer to the slide, that of course if you don't find, if this function is not convex, then it will continuously forever do the iteration, then because they don't find the minimum number, the minimum value of the cost functions. So if you set your f equal to sigmoid, if you set as a sigmoid, then what should be the functions become? So this process will become the logistic regression, because the output from the linear equation is passed to sigmoid function. Once you pass the result from the linear function to as an input function of sigmoid, it will become the logistic regression. And if you set your f as softmax function, then it will become a linear classification for multi-class, which is this part. So that's why I draw this block. I like to draw this kind of block, because you can see that clearly that is how to different between many type of linear regression there, linear method. Dr. Ting used the term linear method. So everything linear means that linear method for regression, you set your f with the identity function. Linear methods for classification, if you prefer the binary classification, or another name for binary classification is logistic regression, then you set your f into sigmoid. And if you talk about I think it's not just sigmoid here. Sigmoid is only if you set f equal to sigmoid, then it will become that is called as a logistic regression. But if you set your f as sinc function, how to draw the sinc function there? So sinc function, the different sinc function is something like this one, +1 -1. So this is y, this is v, sorry, this is v, this is y hit. So if your f is a sinc function, sinc S-I-G-N sinc function, then that is also a linear method for classification, and that classification is a binary classifier. Okay, but that is not called as logistic regression. Logistic regression is a binary classification, binary classifier, if your f is set as a sigmoid function. But if you set your f is equal to sinc function, that is not called as a sigmoid function. and if you set your f with unit step function, it is under this category as well, a linear method for classification, and that classification is for binary classifier. However, it is also called as a perceptron algorithm. Okay, if you set your f with unit step function like this one. So, and then if you set your f with softmax function, then your linear method will become a linear method for classification, and that is under category of multi-class classifier. So you can see that that's why I try to generalize it with this block diagram. Okay, I hope that should clear and can answer your question. That is actually make me to that is make you clear that your doubt over here means that how to distinguish what is different between linear classification, a linear regression, and perceptron algorithm. Okay, so what else? Do gradient descent and backpropagation refer to the same algorithm, or they are two different algorithms? Okay. Actually, gradient descent and backpropagation is the same. It's a similar things. It's a similar means that backpropagation is actually the fundamental behind the backpropagation is gradient descent. But gradient descent is, you can see that when we learn about the linear method for classification or linear method for regression, we already introduced you with gradient descent. But backpropagation is a special term used for neural network, means that for updating the W or updating the theta inside the neural network, you are using the approach called backpropagation, and backpropagation's unit, a basic unit inside the backpropagation is actually a gradient descent. So that's why it's similar, but backpropagation is for neural network, and gradient descent is a fundamental inside the backpropagation. But gradient descent is actually a general term used in finding the updater for the hyperparameter, which is the W or the theta in the previous lecture. So means that doesn't matter is it neural network or linear regression, the one to update the theta, we are using a gradient descent approach. But for neural network, the gradient descent approach is a little bit complicated, because we have a lot of complicated function there, because we have several network. So the whole thing is called backpropagation. But for linear regression, they just simply use the term gradient descent because they are processing a simple function there in updating the W or updating the weight the theta there. So but in neural network, you have a lot of parameter, you have a lot of neuron, so that's why the step there, the fundamental step is gradient descent, but the whole things is called backpropagation. Okay, so it's a similar things. And then the second question is that, or they are two different. Okay, it's the same. So can maximum likelihood also used for linear regression to find the optimum theta? Okay, for this one, maximum likelihood actually is a special cost function for classification only. For if you talk about regression, you need to use the MSE. Okay, but MSE itself can be used to optimize both. Means that you can use MSE to linear regression. You can also use MSE for classification. However, for classification, maximum likelihood or cross entropy work better than MSE. Okay, so that is also answer this question. How much fast I think it's not I think it's not talk about fast. Later I will try to explain to you. Actually, it's more on the which one can optimize better. So in term of if you talk about classification, if you choose the MSE, you cannot find the optimum better than cross entropy, because if you replace the MSE with cross entropy in classification process, it will give you more optimized value of cost function than using MSE. Why that happen, I will try to discuss my slide later. Okay, this is also about the MSE, which one is suitable. In practical, cross entropy is more suitable for classification, but what I explained in my video before is that later when I want to explain to you the neural network, I just scope the syllabus by using only the MSE, or later I also it's not MSE, it's another one, is SSE. I will explain that later as what is SSE. Okay, let me explain that one. Okay, I think it's related to yeah, actually there's a lot of sorry. Okay, actually there's a lot of cost function that I think if you refer to the textbook, okay, of course the previous lecture we used sorry that okay. Sorry. Okay, there's a problem there to explain that. Let me explain in my slide there. Okay. Okay, instead of MSE and cost entropy, which is this one is a cross entropy or maximum likelihood, there's another one which is also called SSE. Okay, MSE is a mean square error, this one is a sum square error. So the difference between mean square error and the MSE and SSE is that if you talk about, of course, sorry, for this one, it should be, of course, in the previous lecture, this later we will use E, but in the previous lecture we use as a J, just remember that. And then this one should be 1/2. Okay, 1/2. That is this one is actually MSE. So what is the difference between MSE and SSE is that for SSE you don't have summation. You don't have summation, you don't have I there. Okay, SSE is the error that you only count according to single sample or one sample. If you have a one sample data and then you find the difference between the predicted predicted output and actual output, and you square it, and 1/2, of course there's no n there, that is called as a SSE, sum of square error. But in the previous example, we don't introduce you with SSE. We try to use the MSE, which is why the equation there have summation and n there, because the error there, now the error is represented by the average value, the average difference between the predicted output and actual output of the whole set of the whole sample of your data set. So that because that I is actually is number of the index represent the sample of the sample of the sample within your data set, means that the total sample inside your data set is n. So that's why you calculate the average average difference or average error as your cost function. But if you use the SSE as a cost function, that one is referred to a single value, a single samples that represent the single sample to produce the error, and that error is actually your cost function. And then if you focus on the MSE itself, doesn't matter SSE or MSSE, if you want to apply for classification, of course in my slide here I use a logistic regression, is actually a classification under binary classifier. So if you want to use that one for classification, you can also you can also use this MSE as well as SSE as a cost function for classification model. But in practical, this cross entropy work better than that. Okay, it's work better than that for classification. That is because if you are using in practical, if you are using this both model MSE or SSE for classification, it will result the non-convex multimodal landscape, which is hard to optimize. What is non-convex? So what is non-convex? Okay, this one I just you can just Google up. I tried. Okay, I just show you the source from the Google. So this is the example of non-convex, or this one you can see there, convex versus non-convex, or here convex versus non-convex. The good cost function is this one, because why this one is better than this one? Because if you remember, when you do the gradient descent to find the optimum value, if your cost function is in this shape, then you only have a one value which is there as a minimum, is a minimum point. But if your cost function result a non-convex shape like this, non-convex function or shape like this, this is called a non-convex, or this one, you can see that there's a lot of a minimum. This is called as a global minimum, and this is called as a local minimum. So this is a very something need to avoid if you talk about those who do the those who in machine learning community. This is the one that they want to avoid. It means that if you use a gradient descent, of course your gradient descent will do a step, mean jump here, and jump here, just to find which one, until you find out, okay, this is the minimum. But during the jumping process or stepping process going towards the minimum, sometimes your updater stop at this position, means that they only arrive at the local minimum, but actually your solution is not optimized, is not absolutely optimized yet, because there's another point which is lesser than this point. This is called as a global minimum. The one that we want to achieve is this point, but during the stepping process, jumping there and jumping there, you can also you might trap into this valley, okay, during that optimization process or gradient descent stepping process. So if your function consists of a convex function like this or this one, then it make your gradient descent might trap into this point. So that is why if you are using MSE or SSE for classification, normally it will produce a non-convex function like this. So that's why people try to introduce to another cost function for classification, which is called as a maximum likelihood or cross entropy, because it will resulting a better cost function that for sure that you can achieve the global minimum as this one. But that does not mean you cannot use MSE or SSE for classification. But the problem is that because of this problem, okay, actually there's a many way to try to find out. Let's say you are using MSE or SSE in classification, and you find out this is your function, and how actually what are the another technique you can use to make sure that your stepping process not trap into local minimum here. One way is you can tune the alpha, because once you tune the alpha, which is the learning rate, if you make it bigger, it might jump a very big step. So might be you can if you tune that, and then might be accidentally it jump very big up until they avoid of trapping in at this point, then you can go into this minimum point. That is one way to find the global minimum. Of course, that is another additional way, but in this point, what I want to say is that another the one that you can, if you want to avoid that happen, one way is that you can also changing the cost function. Instead of using MSE or SSE, you can also use cross entropy for classification, where it can provide better function which is convex, as okay, which is it will convex as compared to MSE or SSE. So back to the question just now, asking about which one is faster. It's not the issue of faster. It's an issue of which one can provide the optimum value. If you use MSE or SSE, if you trap at this local minimum, of course you can you don't manage to optimize you don't find the best W or best theta for that, because the best theta or the best W is at this point. So that's why if you are changing it into cross entropy for classification, it might be the cost function seems to be like this. So then you can have the global minimums there. You can arrive at the global minimums because this function don't have any local value there. Okay, so that is the issue. But of course, I think some of you might not clear is that, because I just give some highlight there. Later in artificial neural network that I discuss after this, I will use, even I'm using a logistic regression or sigmoid function in my approach, and then the error or the cost function there, I still use MSE for that. I don't use cross entropy. So later when I explain that lecture, then you need to remind, you need to remember or remind yourself is that because I want to reduce the scope of your syllabus, meaning that we just focus on discuss the complex things. We want to have a discussion on the big thing about the neural network mechanism itself, which is very complicated. So instead of make you to learn more things about about the many cost function and so on, I just put the scope there. In my example later, I will use I will, in order to determine my cost function there, I will use only the, later you see that I use the SSE for that. And I try to explain a little bit about if I change my cost function into MSE, what will happen actually, what does that affect in my algorithm, in neural network algorithm. But later if you find out, you will find out that I will not explain about this cross entropy, because you already learned this one in the previous lecture. So I just assuming that you know that when discussing about the cost function in neural network, everything's in previous lecture can be used in neural network algorithm. But I just reduce the scope into, I just avoid of using this one, because we want to make sure every student get the fundamental, means that of course at least you get the basic and you know the artificial neural network algorithm, how actually what is the happen inside the neural network when you do some training process. That is the main objective of these courses. So that's why later if I explain the example, you will see that I'm using the SSE as compared to MSE or logistic or cost entropy, because I think I will explain a little bit MSE because I want to relate with the previous lecture, but I will not use the cross entropy in calculation. That is the thing, because we want to have at least you know the behavior of neural network, then it's enough for because that is our cost outcome. You want to at least you know the surface knowledge and the fundamental behind the artificial neural network. And at the same time, you in your mind you know that actually this is only the fundamental. Later when you do the assignment, if you, because of course the assignment we ask you to, we give a problem, you need to solve it in the MATLAB, and you find out MATLAB have a lot of advanced techniques. And of course MATLAB for sure will use the cost entropy for classification as compared to SSE or MSE. That doesn't matter, because we just introduce you with several approach in several type of cost function, because later when you try to apply the assignment, then you know that you have a several advanced technique than the fundamental. Because in this syllabus we try to focus on the fundamental, the content itself, we focus on the fundamental or the basic approach, because we want you all to feel how actually the pattern, how actually the algorithm works. And then of course we try to simplify all the mathematic operations, so then you have the feel on how actually the flow of the data inside the neural network. So that's why later you see that I only using the SSE for neural networks. But of course in practical, SSE or MSE is not relevant anymore for classification. So that's why during the introduction there, I just remind all these things, so then you don't feel shocked when I try to explain the step-by-step algorithm itself. Okay, I hope that's clear about that. Okay, that is also solve this one. Okay, talk about the MSE, and then I think yeah, this one same. I answer this one because entropy is better for classification. Okay. Okay, I think this one, again this one. Okay, this one is about activation. Activation function later we will discuss that later in because this we don't cover that yet. That is too advanced. Later we will explain the activation function because we don't start neural network. We just start I just explain the history about neural network. We don't start the neural network flow itself or the neural network mechanism itself. So because I need to explain that one first before we can explain the type of activation function later. But I don't actually my target, we don't go deep into comparing the activation function since someone have asked about this. So then I will try to explain that a little bit on what is the difference actually is the there's some timeline there, or the history behind that, means that which one have been introduced first, and then this one is not good, then someone introduce another activation function because of try to solve the problem happened to the previous activation function. So that's why there's a lot of activation function. But of course, if you talk about artificial neural network, the most popular is sigmoid functions. Okay, it's a sigmoid functions. Okay, I hope I answer all the question. I hope you can hear the explanations there.